type of speed measurement, and in the part 2 of speed measurement we people will try to complete the entire electrical type of speed measurement. So as I have already told you people that the contents that we are going to study is electrical type of speed measurement. Introductory part we have covered. In that one, the general definition in terms of electrical one, or in terms of subject wise, that is nothing but rate of change of position of an object in any direction, either means clockwise or anti-clockwise, or it is the ratio of distance per time that has been covered, and the unit for that one is meters per second. So this is the brief overview which we people are utilizing as a sense to measure the speed by various means. Now different types of tachometer, as generally mechanical type of tachometer we people have seen. The rest of remaining is electrical type of tachometers. In that electrical type of tachometers, there are three different types of tachometers. One is eddy current or drag cup type of tachometer, and another one is DC tachometer and AC tachometer. Furthermore, in the next lecture, whatever we people are going to discuss is contactless electrical tachometer. So the principle, the name itself indicates the significance that in mechanical devices are fruitfully incorporated to generate the required output for the measurement of speed parameter. Whereas here you people means in the previous case you are directly getting the output in terms of not in the form of electrical one, but you are directly getting the output in terms of revolution per minute on the indicator or the handheld device which we are using for the measurement of speed. Here, in electrical type of tachometer, the resultant output of the speed is calibrated either in terms of your voltage or current, and that voltage and current which is generated is further converted in terms of speed. So, in the next lecture, whatever point we are going to discuss is contactless electrical tachometer. In that one, magnetic pickup tachometer, photoelectric tachometer, stroboscope is there. These contents we people are going to go through, and in this one, electrical tachometer. Actually, electrical tachometer, or what is tachometer? In generally, we people in our laboratory also we are having the tachometer. Now it can be electrical type, it can be your mechanical type, it can be your contactless type also. So tachometer is nothing but it is one type of device that is trying to generate the resultant output in the required form. So over here, eddy current or drag cup type of a tachometer. Now, on what principle this eddy current type of tachometer is working, and what is the working principle of eddy current, so that whatever the speed that you people are going to measure based upon the concept that we are utilizing for the measurement of speed. So here the eddy current concept has been used for the measurement of speed. How this eddy current concept is incorporated? So eddy current is nothing but one type of magnetic field based upon the permanent magnet that has been generated. Your concept will be clear over here that eddy current tachometer uses an interaction of the magnetic field, as I have specified earlier, generated by a permanent magnet and a rotor whose speed of rotation is proportional to the eddy current generated. Now, in electrical type, as I have discussed earlier, that the output which is going to be generated is either calibrated in terms of either voltage or either current. So here the resultant output is calibrated in terms of eddy current. So the speed of the component which we people are interested to measure, that speed of rotation will be proportional to the eddy current generated. Now, how the eddy currents are generated? It uses the interaction or the communication of magnetic field. How this magnetic field is generated? It is generated by the permanent magnet and the rotor. Permanent magnets are associated across the rotor, and that is going to generate the proportional eddy current using the eddy current type of tachometer. The current tends to be deflect a disc. Now this current is going to deflect a disc. And on what basis? Depending upon the generation of current. If your current is less, at that time the deflection of the pointer will be at the minimum side. Suppose I am having one dial gauge. This is the dial gauge and here is the pointer. So there will be a deflection of the pointer. Now what is going to happen? This is the pointer. It is associated at the minimum one, and as the eddy current start increasing, your pointer will also start increasing. Likewise, the output you people are going to get. So it is starting from minimum to maximum depending upon the generation of eddy current. So eddy current tends to deflect the disc that is mounted on the shaft and restrained by a spring through a certain angle. So the deflection of the disc, which is rigidly connected to the pointer, that I will show you, indicated on the dial. So used for the measurement of rotational speed up to 12,000 RPM with an accuracy of plus or minus 3%. This is the concept that we people are using. This one is the driving cable. This particular one is the driving cable. This is nothing but rotating magnet. This one is your drag or cup, which is stationary one, and here is your spring. This spring is going to exert a force, and across this particular spring, actually here is the pointer, and over here this is nothing but the scale. Okay, so how this is going to work? Now this particular aspect over here, actually when this rotating dragon, this will try to rotate. This rotating magnet will rotate. But at the same time, what is going to happen? This drag cup is stationary one, and the gap between that one will be the minimum. Now, the flux which is going to be linked, across this particular part, between these two particular parts, it is going to generate the flux linkage between this one. So the movement of the dragon. So over here, what is going to happen? That when this rotating magnet will rotate, your dragon cup will also try to rotate. And when this dragon cup is going to rotate, now what will be the motion that is generated by the dragon? It is totally depend upon the rotating magnetic field. It is totally depend upon the rotating magnetic field. If the eddy current generated is based upon the rotation of the magnetic field, automatically when the rotations are going to increase, at that time the eddy current which is going to be generated, that particular eddy current will be more in number, and the spring which is going to be exert a pressure, this particular spring which is going to be generate a pressure will totally depend upon the eddy current which is generated, and this will either increase or this will either decrease, will depend upon the speed of rotating magnet. So over here, if your speed is more at that time, the eddy current generated will be more, and the force which is going to be exerted on the hairspring will also be more. So the pointer, this pointer will try to deflate. Either if suppose this is the zero position, then this will try to move towards the inner side, and here on the dial gauge it will try to provide the rotations. So these rotations that are to be generated will be totally depend upon the eddy current that has been generated due to rotating magnetic field, and the opposing force that has been generated by the drag cup. So this drag cup is generating opposing force, exerting a force on the spring, and tends to move the pointer on the dial gauge. So you are directly going to get the output on the terminology, or on the dial gauge. So here also one instrument. So this is nothing but the instrument. This dial gauge, if I represent, it is having the black color. So I will represent with a red color. So as your magnetic field is increasing, this dial gauge will increase, and it will try to show the speed with the help of pointer. Now, but the point movement of this white pointer will totally depend upon the this is multiplying factor. This 1000 is multiplying factor. Suppose 1 multiplied by 1000, so output will be 1000 rpm. 4 multiplied by 1000, so output will be 4000. So it is having multiplying factor. So don't get confused with the term that it is not showing the output in terms of 10,000, as I have specified, starting from 600 to 10,000. So up to 8,000 they have shown. So you can increase it. 1000 multiplied by 1 means 1000, and 1000 multiplied by 8 means 8000 rpm you people are going to get, as you are going to connect this particular dial gauge to the means this assembly which is shown, magnetic drag tachometer. So it is going to exert a force on the spring, and that spring will tend to rotate the pointer towards the upward side, and this motion of the pointer is totally depend upon the eddy current that has been generated. But eddy current is the function of the rotation of the speed, nothing more than